I'm Tuka Muhammad and I'm going to talk about the navigation system. Our navigation system consists of 3 stages. In the first stage, we use GPS to get the rover's longitude and latitude. Then we calculate the distance between the rover and the waypoint. To get the angle the rover should be rotated to reach the waypoint, we subtract 2 angles. The first angle is the azimuth angle which we get from the GPS, and the second angle is the heading angle which we get from the IMU. Now the rover has the distance and the angle to reach the waypoint.
To avoid any obstacle, we use a LiDAR. It provides 360-degree scan field. Using LiDAR, the distance between the rover and any obstacle can be calculated. Each distance is calculated according to a fixed point in the LiDAR. We divide this data into regions. The front region is our goal. It shouldn't have any obstacle. If it has, the rover should rotate right or left to avoid it. Now the rover can autonomously choose the best path to reach its goal without hitting any obstacle.
I am Ahmed Hazem. In UGV Task 2, the rover must reach a specific destination that is given by the judges. We receive the coordinates from the judges as a polar coordinates, magnitude and direction. The rover must rotate and move to its direction to reach its destination. We rely on the compass in the IMU so that the rover can move to each destination and rotate a specific angle that it can move to each destination. As for the distance covered by the rover, we rely on the odom coordinates and odometry to calculate the number of ticks and the number of rotations by the wheel to reach its destination. Afterwards, the rover moves and reaches its destination.
I'm Omar. I'm going to talk about computer vision task. By the end of second stage, the rover will start searching for black box located in 10 to 30 meters away from the gate. After detecting the black box, the rover will start moving autonomously towards that box. When the rover is at an appropriate distance from the box, it will start rotating around it to find the side which contains a random number. Through the model, it will be able to use that number and send it to a control station with displayed message on the screen. We use UGV4 as a real-time object detection model. We use MNIST dataset to detect the handwritten digits.
UGV version 4 model is used with our custom dataset to detect the black box. MNIST is used to train the convolutional neural network that can detect the numbers. The model will run on Tips AI Myriad X modules that came with OKD camera. It's a real-time spatial AI powerhouse. It allows to build computer vision and deep learning that approach human-level perception in minutes. To allow Tips AI to use custom trained models, it must be converted into Myriad X plot file format. First, we train the model, then we get weights file converted to plot file that can be used in our camera. In order to handle the decisions that will be made depending on the output of the model, DepthAI with packages are used to facilitate the integration of DepthAI and OKD with ROS. I'm Mary for Computer Vision team.
I am Ron Mohammed, member of Communication Sub-Team. The communication system is distributed between the control room and the rover. In the control room, we will have an omnidirection antenna operating at 22 MHz and assigned to it a static IP. The antenna will be connected to the visualization laptops wired and connected to the router wireless. On the rover, we will have a router connected to the IP camera wired. The stream of the IP camera will be received on the visualization laptops using UDP protocol.
My name is Farah and I will talk about our hardware system. Our hardware system consists of 3 main boards. The first one is power distribution board to provide suitable voltage to each load. It includes relay, buck and diode to protect it from reverse polarity. Also fuses and circuit breaker for short circuit protection. Current sensor to measure motor's current. Finally, 7-segment LED and Zeners for battery level indication. The second one is shield circuit. We have several shields like motion, GPS, IMU, encoder and metal detection. Finally, the third one is feedback circuit to look out and troubleshooting system failure.
I am Mahmoud from the mechanical team. We selected 4-wheel skid steering mechanism to design our rover. We designed a motor bracket to place the motor in to secure it from shocks. Our motor has 380 kg/cm torque. The suspension system in the rover is similar with that one in the cycle, which absorbs vibration. We used the aluminum profile open-built V-slot 2020 mm to fabricate our rover because it's easy to fabricate, disassemble, mounting and customizable.